the basis of plus R and minus R type resonance. So we have to identify in the given question whether it is plus R resonance or it is minus R resonance, right? So let us start. The first question is CH2 CH Cn. So here it may be written as CH2 double bond CH C triple bond N. Here is the pi electrons, sigma and pi electrons. The conjugation is present and the atom attached is this. This is the atom attached. So in this the nitrogen moving, nitrogen attracted the electrons and these pi electrons come this side. So in this you may clearly observe in this the atom attached is this carbon and the pi electrons movement or electrons movement takes place towards the atom attached. In this case the electrons movement takes place towards the atom attached, and in the species in which the electrons movement takes place towards the atom attached shows minus R type resonance. So this is the minus R. Right? Now come to the next species. Next question is this. A species is given and the group is CH. Now in this species, these pi electrons are there. Here is C, here is H and here is O. So pi electrons, sigma bond, pi electrons conjugation, and oxygen is more electronegative than carbon. That's why it attracts the pi electrons towards itself and the pi electrons movement takes place towards the atom attached. This is the atom attached, carbon. This is the species. This is the atom attached. So electrons movement takes place towards the atom attached. That means this type of resonance where the electrons movement takes place towards the atom attached is minus R type. So it is minus R type. Right? Now come to the next. This is here the oxygen atom is attached atom and this has the lone pair of electrons, and here is the benzene ring. So benzene ring pi electrons are in conjugation with these pi electrons. So electrons sigma pi electrons, lone pair sigma pi electrons, and the resonance which takes place. And this species the atom attached is oxygen and the electrons movement takes place away from the atom attached. That means this type of resonance where the electrons movement takes place away from the atom attached is called plus R type. So this is plus R type. Now move to the next question. This. So in this question, if I am going to write it here, this is the acid group. Right? So here and the pi electrons are there. The pi electrons, sigma and pi electrons. So here the conjugation is present and the movement, oxygen is more electronegative than carbon. It attracts the pi electrons and these conjugation pi electrons moving towards the atom attached. Atom attached is carbon. This is the species given, this is the atom attached. So here the electrons, pi electrons moving towards the atom attached, and that's why it is minus R type. Right? Now come to the next. This. In this the benzene is there. And the halogen is present. Chlorine, halogen. Halogen has a lone pair of electrons on it. And these lone pair of electrons, sigma bond and pi electrons are in conjugation. So the delocalization of pi electrons takes place. In this, the atom attached is chlorine and with the conjugated system. So the electrons movement takes place away from the atom attached. That means it is the plus R type. So now I think each and every concept about the resonance plus R and minus R type has been clear to you, right? Now next move to the effects of resonance in the molecule, right? For example, bond length, the stability, the acidic strength, the basic strength. Let's move. The one thing I would like to see that if you like my lectures, if you like my method, if you like my questions, my answers, method of teaching, then please like, subscribe and share. Share the lecture to the students as much as you can, because each and every concept must be clear to each student, right? So please like, subscribe and share. Now come to define the resonance effect. Actually, the resonance effect is the polarity produced within the conjugated system, right? Between pi bond and pi bond, between pi bond and lone pair, or within or any other conjugated system, right? So the polarity is produced within the conjugated system because of the resonance or conjugation, right? So the polarity produced in the molecule due to conjugated system between by the interaction between the lone pair and pi bonds, or between two pi bonds, or between any other conjugated system. So mainly the polarity is produced within the conjugated system. That is the effect of the molecule of resonance, right? For example, interaction between pi bond and lone pair. Here is the pi bond and if it is going to delocalize, it comes lone pair here, right? And again this comes to here. So it is pi bond and lone pair, pi bond and lone pair, right? Now between pi bond and pi bond, if here is positive charge and these pi electrons shifted towards this, and the next resonating structure will be pi bond here and positive charge. Now this carbon atom. Now this again move, right? So now next is lone pair and pi bonds, between lone pair and pi bond. Suppose this is the lone pair, positive charge, and this time this shifts through this direction, and here comes the double bond, right? This again move. So this is the interaction between pi bond and lone pair, pi bond, lone pair, pi bond, and you may clearly observe that the polarity is produced within the molecule due to the conjugation, right? So this is the resonance effect within the molecule, that is the polarity produced within the molecule due to the conjugation, due to the delocalization of the pi electrons, right? Now next, move to the next topic. One more thing I would like to say, if you like my methods, my description, my method of teaching, and my questions, my examples, if your concepts has been clear, then please like, subscribe and share. share to all of the friends that you know, right? So because the concept must be in the reach to the every student. So please like, share and subscribe. I will make more videos on the different topics, more questions, more examples. So please like, share and subscribe. Thank you.